Hello class 9. Let's solve the exercise 7.1 from your end. Question number 6 in figure AC is equals to AE. So this is a very interesting diagram. Here we have AC that is equals to AE and AB is equals to AD. It's given here. Again BAD is equals to EAC. Angle BAD, this angle is equals to EAC. This right angle right here. Okay. We have to show that angle BC is equals to DE. BC is equals to DE. So BC belongs to the triangle ABC and DE belongs to the triangle ADE. If we can prove that ABC is congruent to ADE, then we can say that this total angle, or rather this side, is congruent to this one, or corresponding sides. If they are congruent, then these are the corresponding sides. So how can we prove that ABC is congruent to ADE? Here we can see that for triangle ABC, AB is equals to AD, and for this ABC, AC is equals to AE of triangle ADE, right? We have two sides which are equal. Now if we can prove we know the third sides are not given, so we can't use SSS. But if we can prove that the angles between them are equal, then we can say that we can use the SAS rule. Now if we look at BAC, okay, BAC, we can see that BAD plus ACD is the total angle. Again, if we take the triangle BAB, ADE, then we have the side AEC, the angle AEC plus this angle DAC. So we can see that DAC is common in both the triangles, right? So let's write down. We have angle BAD is equal to angle EAC. Now if we add angle DAC on both the sides, this is the common angle between them. So if we add it here, DAC, and on the right hand side also DAC. So BAD plus DAC becomes DAC, and EAC plus DAC becomes DAE. That means this angle and this angle. So therefore, if we take the triangles ABC and ADE, we can say that BAC is equals to DAE because we proved it. Then AB equals to AD. AB and AD are equal, given, and AC equals to AE, that is also given. So we can say side, angle, side. Again for this one, side, angle, side. So using the SAS congruence rule, we can say ABC is congruent to triangle ADE. Please be careful about the names again. Now, since these are congruent, we can say therefore by CBCD, the third side is also equal. So the third side is BC and here DE. The second two, here also the second two, BC is equal to DE by CPCD. Question number 7 says, AS is a line segment and P is its midpoint. D and E are points on the same side of AB such that angle BAD is equals to angle ABE and angle EPA is equals to angle DPB. Show that triangle DAP is congruent to EBP. Okay, so here is the diagram, and here it is said that AS is a line segment and P is its midpoint. So AB is a line segment and P is its midpoint. D and E are points on the same side of AB, such that BAD, this angle is equal to ABE, that is this angle. These two angles are equal. EPA is equal to DPB. EPA, this angle is equals to DPB, this angle. So these two angles are equal and these two angles are equal. We have to show that DAP, this triangle DAP is equals to EBP, this triangle, right? So we can already see this angle of this triangle is equal to this angle of this triangle. Again, this angle of this triangle is equal to this angle of this triangle. But we can see that EPD is a common angle between these two triangles, right? So we can actually take APD is equal to BPE. Reason? These two are already equal. So this plus this is equal to this plus this. Let's write it down. As P is the midpoint of AB, AP is equals to BP. It is already given P is the midpoint, so AP is equals to BP. Angle EPA is equals to DPB. Angle EPA is equals to DPB. It is already given. Now adding EPD on both sides. This angle, we are adding this one to both the sides. So if we add it, we are getting angle APD is equals to angle BPE. Now in triangle DAP and EVP, let's take these two triangles. We can say that PAD is equals to PBE. This angle PAD is equals to this angle is equals to this angle PBE. It is already given. Okay. Then AP is equals to BP. It is already given. And also DPA is equals to EPB. We have just proved it. Okay. DPA is equals to EPB. Okay. Therefore, we can say by angle, side, angle. Again, angle, side, angle. We are getting this as ASA congruency rule. So, triangle DAP is congruent to triangle EBP. So, if these two are now congruent, we can say that AD is equal to BE by CPCT, right? AD is equals to EB. We can get it from the name as well. Question number 8. In right angle triangle ABC, right angled at C. So we have a right angle triangle ABC. Okay. Angle C is 90 degree. M is the midpoint of the hypotenuse AB. So AB is the hypotenuse as angle C is 90 degree and M is the midpoint of AB and produced to a point D. So if we extend CM, we'll get D such that DM is equals to CM. Again then for CD, M is the midpoint. So we can write CM equals to DM and AM equals to BM, right? M is the midpoint of both the lines. Point D is joined to point B. So point D is joined to point B. Show that AMC is congruent to BMD. AMC is congruent to BMD. So we can say these are vertically opposite angles, right? What else? We have just seen here that DM equals to CM, right? CM equals to DM. So CM of this triangle equals to DM of this triangle. Again, M is the midpoint of AB. So AM of this triangle is equals to BM of this triangle. So what did we get? S angle S. Side angle side SAS rule. So since M is the midpoint, AM equals to BM. In triangle AMC and BMD, we have CM equals to DM. Then angle AMC equals to BMD vertically opposite and AM equals to BM. We have just proven. Therefore, we can say by SAS congruence rule, AMC is congruent to triangle BMD. Next, we have to prove that angle DBC is a right angle. DBC is a right angle. So we have to prove this angle is 90 degree. So how can we do so? Since AMC and BMD are congruent, so these two are congruent to each other. Therefore, we can say that MAC, that means this angle, is equals to MBD. That is this. How did we get it? From the names, of course. So MAC is equals to MBD, right? So the name here. But They form a pair of alternate interior angles, isn't it so? This angle is equal to this angle. We have just proved it. This angle equals to this angle equals to this, because these two triangles are congruent. Since these two are equal, so if we take these two as straight lines and this as a transversal, these two are equal. Since these two are equal, definitely this angle is equal to this, means they are alternate. So we can say that these two are parallel and AB is the transversal. These two are alternate. Therefore, these two AC and BD are parallel. So if they are parallel, then if this is 90, this is also 90, right? Interior angle, sum of interior angles, right? If this is 90, this should be 90 because sum of the interior angle is 180. Let's write it. So therefore, we can say that BCA plus DBC, that means these two angles, is equals to 180 because DB and AC are. So since the sum of the two angles is equals to 180, but angle C is 90, so we can say that 90 plus angle DBC equals to 180, and hence we'll get angle DBC as 90 degree. Next, we have to prove that DBC is congruent to ACB. So DBC will be this triangle and ACB will be this triangle. We have already seen these two angles are 90, right? And BC is a common side. Now we have also proven that these two triangles AMC and DNB are congruent to each other. These two are vertically opposite angles, therefore their opposite sides are also equal. So we can say DB is equals to AC. So DB equals to AC, the angle B 90 degree and BC are common. So therefore we can say by SIS rule they are congruent to each other. So in AMC and BMD we'll get AC equals to BD. Then in the two triangles BD equals to AC, then these two angles are 90 and BC is a common side. Therefore by SIS congruence rule they are congruent. Next we have to prove that CM is equals to half of AB. So CM is right over here and that is equals to half of AB. So we have to bring a relationship between these two lines. So since M is the midpoint of CD, we know CM is equal to half of CD. So let's write that. So these two triangles are congruent, right? These two triangles are congruent. If they are congruent, we can say that DC is equals to AB. DC is equals to AB, as because these two triangles are congruent right here. DC is equals to AB. Okay, first and third. Now we know DM equals to CM. It is already given in the question. Now CM is equals to DM and DM is equals to half of CD. So half of CD. Again, DC is equals to AB. So we can write half of DC equals to half of AB. Hence, CM is equals to half of AB. Hence proved. Hope everyone could understand all the sums properly. Hope the session was helpful to everyone. Thank you for watching the video. Bye bye.